Hello and welcome to the fourth video in this series. In this video we're going to be taking a look at the three different nodes. So we're taking a look at the constant, the color temperature and the FlipFlop node. So we kind of got up to this point at the moment. These are quite basic in principle. The constant and color temperature are like very basic nodes. FlipFlop's just a little bit more complicated. So we'll cover that with a bit more detail. So the first thing, we'll just take a look at the color temperature node. This works by reading like Kelvin values. So if we just right click show help on this, you can see we've got this color temperature. At the moment it's got a default value of 4000 Kelvin, and this just allows us to pop in basically a numerical temperature and then output the correct RGB value for that. So at a low temperature it's going to create an RGB value of a really kind of low dark red, and then as we kind of increase this value it's going to go more towards like your orange, yellows, and then at the hottest point it will be pure white. So you might want to kind of rig this up to say if you had like some kind of heated material, and you want to go through all those different values and you want to kind of specify a particular temperature for it starting at and then cooling down maybe, that could be an option for using these nodes. But for me this is something that I'll probably hardly ever use. If you look at this, by default it's got a temperature value of 4000. If we put in 100, you can see it's gone red. If we put in a value of like 2000, go more towards orange, 3000, go more towards like orangey yellows, and then if we go to something like 8000, we're pushing towards white, and it's working its way through the spectrum and through that range. Okay, so the next node is the constant, and it's kind of it's a very simple node. All it does is it holds just a data type and the data, and it just exports or links that data into a port on another node. So by default it's set to real, and you can change these to all these different types here, and you just want to be mindful of making sure that you link in the correct data types with the correct nodes. So at the moment it's just it's feeding this FlipFlop node with a value of 1 and 0, but we could do the same thing. So if we change this, because essentially it's just like a boolean value, so we could change this to bool. Yeah, and then it's doing the same thing. So with it being checked is 1, unchecked is 0. So we'll just change that back to real so you can see the numbers down there. So that pretty much covers the constant node. You'll probably find that you're replacing a lot of these out with user data. So you'll be adding user data to nulls to your tags, and then feeding that data through like your interface directly into these nodes. Okay, so now we understand what these do. We'll just move on to the FlipFlop. So if we take a look at the scene at the moment, we've got a let's move this across. We've got a value of, let's just change this to 1. So we've got a value of 1 from this constant and a value of 0 from this one. And essentially what happens with this FlipFlop node is it's currently set to true. Now the way that this works is it works like this. You've got 2 inputs on this. Now inside this it's almost got a more complicated switch. So on one of the inputs it feeds directly back into the other input. and then the output from that feeds directly back into this one, and then it feeds your output. Okay, so you don't really need to understand how it works in principle like this, but probably the easiest way to understand it is if we just kind of have a play around with it. So if I change, say, this constant value and change this to 1, you can see how the output's now false, so or 0. Now if I change that again back to 0, it won't affect the result, the end result. Okay, so the only way that can be affected is if the other input changes. So then if we go to this input and we change this to 0, so it doesn't, regardless of whether it's kind of 0 or 1, it's just a change in state that swaps the output. So change it to true, change that to 0, and then yeah, you've got that same state. Again, we can go back to this, change this one to 1, change it to false. So it needs to be triggered alternatively by both of the inputs. And probably a good way to understand that is I found this this GIF online, and if you take a look at this, so you can see it receives an input here which triggers the output on this one, and you can see as it loses that value, so it's 1 and then the 1's off, it kind of locks on. So it's on, off, locks on, and it's waiting for the input to go on, off. Okay, so for the Python part of this, I'm not going to base any Python on any of these in particular. So there's no practical examples using Python for the kind of color temperature setup. I'll just kind of I've left that, and I've not really done anything for the FlipFlop option either. Constant's very obvious; it'll just be a stored variable. FlipFlop could be done by a series of different statements in the code, but what I thought I'd do is just cover some more of the basics of breaking down a matrix and just extracting the values from a matrix. So let's just bring up Python. So we'll just pull in a null, go to tags, scripting tags, Python, and then we'll just pull out the data from this null that's on here. So again, as we've done before, we'll do we'll just call this object. So obj equals op dot get object, and that's declaring a variable and putting that object into that variable there. And then we can extract the matrix from this. So we can go. We'll just call this matrix equals obj dot get mg, and then we'll just print matrix, and again we'll just dock the console onto the side just so we can see what's kicking out. So just reset this, execute. So we've got the matrix here, and as we've discussed before, this is 4 separate vectors. So offset, which is the position, and then you've got your matrix 1, 2, and 3, which is essentially x, y, and z. And the length of these vectors will determine the scale also. So if we want to just extract, say, one of these in particular, maybe just the offset, what we can do is we can go into this, and we can just print out. So instead of printing the matrix, so we can get that information into this variable by using this command, or if we just want the offset value, we type in dot off, execute, you've got this value here. Or if we just want v1, we've got that vector there, and again v2, execute. We've got this vector here, and we can do that with v3, would obviously give us this vector here. So we've taken a look at how we can extract the full matrix. We've looked at how we can extract particular vectors from the matrix, but what if we just want one individual value, or one part of one vector? And we can do that by extracting it from a list. So we can do that by, if we go into this, so we've got, at the moment we've got, change this to off again. We'll just put in brackets and we'll put 0. Actually, we'll just move, let's just move the object just so it's giving us some numbers that we can understand here. So execute this. So you can see that offset vector there is this, and that's kicking us out. So we've moved the X and Z. So we've changed some of the numbers here. Now if we just want, say, the first one, let's get that by putting in brackets 0, and then just print this again. So you can see that this here, which is referencing 0, is referencing just this number. So that works by, we can extract one of these by 0 is this one, 1 is this one, and 2 is this one. So the numbers that we're referring to in the brackets link directly to the three values in the vector, so x, y, and z. Okay, so once we've extracted just like the single data or the single position, we can then use that, and it just makes things a lot easier to calculate. So because a lot of the time you probably won't be calculating, or multiplying, subtracting full vectors, you might just want to extract an individual number, an individual value, and calculate things that way. But I hope you found this useful. Thanks for watching. Please like the video if you enjoyed it, and I'll catch you on the next one.